In this video, we'll work with IPtables as a safeguard to limit the attack surface of our Linux target. As you can see from our Nmap scan, we discovered a number of different ports and services that are exposed to anyone from anywhere. With IPtables, which is a host-based firewall, we'll be able to limit the attack surface and limit the visibility to these ports and services to only systems that we designate. As a precursor, it's important to note that we have a range of different ports and services that are currently visible. With IPtables, we'll only make port 22 visible to our Kali virtual machine, and also port 80 will be visible to everyone because it's a web server. To get things started, I prepared a little transcript with the different commands that we'll execute. So I will kind of go over these commands and then explain what they actually do. So for this particular lab, we need to make sure that you're signed into your Metasploitable target, and we'll be making the changes on the Metasploitable target. So log in with the MSF admin username and password, then go ahead and from the terminal elevate your privileges with sudo space -i. From here, what we will do is we're going to check our IP configuration and go ahead and note the IP address for your ETH0 interface, which in this case is 10.10.1.10. That will be important. So do the same thing for your Kali. Sign in, look in the IP address. In this case, it's 10.10.1.8. So what we'd like to do is allow the IP address of our Kali to be able to talk to the target on SSH. Okay, so once we have this, the next thing to do is we will review the IPtables. If you'd like to find out additional information about IPtables, you can use the manual page by executing the man command space IPtables. So from there you can find out it's an administrative tool for the host-based firewall. It gives you some examples. If you hit the enter key, it will walk you through different options and examples of usage. Now, to get out of this menu, you press the Q. So press the Q on your keyboard and you should be able to exit out or quit. To go through the actual list with commands. So what we need to do is from the terminal and the Metasploitable target, execute different commands. The command to go ahead and list the existing rules is IPtables-L. To flush or remove any existing rules is capital F. Now, by default, what we need to do is define a policy that will essentially drop any incoming traffic that is not explicitly allowed. So unless we specifically tell that a traffic or connection is allowed from a specific source address and port, it will be dropped. Now, if you're looking into any forward rules will be also dropped, any output. So output is the outgoing, right? So for the outgoing, everything will be dropped unless it's explicitly allowed. Okay. So what will happen is we're looking through these different commands, and it's interesting to note what they would do. Now, the one thing I did is this drop. If we leave that configuration option in place, it will cause everything to be dropped, even if it's outgoing, unless we specify. Now, in the case with a web server, if we do this, let's say that we allow connection from the internet. It's a web server, it's servicing our marketing material, but we drop any outbound connection, so from us to get a response. So the end user is going to be connect, but then they're not going to see anything because we're not sending anything back to them. So the drop is acceptable in a highly secure environment where we monitor every incoming and outgoing connection, and we are very strict in who can see a response. Okay. In environment that we're working with, we will allow established connections. So anything that was established from our system out will be allowed. This will give us some flexibility and in our configuration. All right. So we need to execute starting with these commands in your terminal. Okay. So iptables space, these are case sensitive, okay? Enter them as you see them here. And then what we need to do is for troubleshooting information, we're gonna allow our local interface. So iptables dash input I, local interface loopback, and then JAccept is the actual statement and condition to accept the connection. Now, the next thing is with iptables, we're gonna append incoming connection source. We're actually going to use this particular IP address. Now note, for the Kali Metasploitable in this particular example, the IP address is going to vary from your environment. You need to translate this IP address to whatever is the applicable IP address for your environment. In this particular case, for your Kali VM. Okay, so for your Kali VM, only this IP address will be allowed to connect. So if Kali doesn't have this IP address, change it to whatever it does. Now, if you noticed at the beginning, I have my Kali in .8, and that's on purpose. I wanted to showcase the actual simulation of how this works. Okay. So what we're doing in here is we're doing the source port is 1.7, the interface is ETH0, port TCP, we're matching TCP connection, destination port is 20, we're matching the connection tracking, and then the state of the connection is new, established, and we're going to accept those. Now, for doing port 21, 22 is the same. The reason for 20 and 21, this is FTP data and this is FTP. The next thing we need to allow is iptables, and this is the actual port 80 for our web traffic. So the same connection here is just for port 80. Now, ideally, you can do dport 20, 21, 22, and so on. But that kind of makes it complicated. Sometimes you want to change the rule to allow FTP but not HTTP or vice versa. And that gives us some flexibility, different ways to slice and dice. The next thing we will do is iptables. So, of course, you can group this one in here. It doesn't matter. It's more or less a logical organization. I'll show you how that looks like in your actual iptables. So to disable ping, and we're going to do iptables space dash capital A, append the input ICMP, and then for the outgoing message we're going to reject. So what we're saying here is when we send an ICMP packet, we send a request for response from the target, and if the target is willing to respond, it's going to send a reply. We're rejecting those, and when we reject them, we're going to actually specify as part of it that the rejection is host unreachable. If we were to drop, there should be a timeout because it's a reject, it's a host unreachable state. Now, also what we're going to do is we're going to log some packets, okay? iptables, we're going to enable logging. After we enable logging, we want to go in and all remaining incoming connections are actually recorded into the logging file. Once these connections are logged, we want to specify that we're looking into connections that are dropped, okay? And for those, the log prefix is going to be iptables packet dropped. Now, finally the packets that don't make it is incoming, matching the limit of 2 per minute, will be dropped. So to review the packet in the ones that are being logged, we're going to provide a command. Now if you were to manually block an address, we're going to use the -input. Source is the IP address that we're using, and then the drop command. So this way we're manually dropping. If you remember this approach, we're dropping everything by default unless it's explicitly allowed. So this is not necessary, okay? But if, let's say, on port 80, because we're allowing anyone, we want this particular address, we find that it's malicious, we don't want it to communicate with our target on port 80, we can append a rule like this one to drop. And what is going to happen is when this address tries to connect to our target on port 80, what will happen is they will receive a timeout. Now the next thing we will do is we're going to save the configuration. We're going to save with this specific command into 2 files. One of the files is going to be used the pre-up and the post-down. We're going to configure our internet interface to actually use these 2 files. This will allow us to make sure that the IP table rules are saved after a reboot. So unless you save your IP table configuration and then assign it to your interface, these changes will vanish. They're temporary. You restart, they go away. So with this in mind, if we go in to here, IP tables, we're gonna list, and I had a wrong command here. What happened with my looks like I froze up my Metasploitable machine, but just an opportunity very quickly to reset it and start it over. So while this is actually going ahead and restarting, I'm going to come into our Kali. Again, know the IP address. Okay. The IP address is 1.8. We had 1.7. As soon as that goes back into the interface, we'll be able to interact. Okay, so the saved file from IPtables with this command is going to look like this, generated by IPsave. It's going to tell you the input drop, it's going to tell you the output accept, the login that we enabled, and this correlates to these commands that we put in. If you put them in this order, once they're entered, they're going to look like this. Now you're not going to have the comment field, okay? The comment field is something I manually entered. But if you notice, all of this is in here, and then you have a commit to actually execute. So it looks like our interface is up. Our IP address is 1.10. So let's go ahead and test what happens with our ping. What is this? Destination port unreachable. Okay, so we can tell if the target is up. What we can tell actually from this is unreachable, there's a firewall in place. If it was a drop state, it's going to have a connection timeout. And let's look at what that actually looks like here. So let's do nmap, and let's do looking for ports 21, 22, and 80, because those are the ones that we know are going to be showing us open for certain systems. We're going to add verbosity, and we're going to do our target, which is okay. So let's see what shows as opened. You see port 80. Port 80 is the only port that is actually opened, and this is because I'm not in the specific IP address. Remember, my IP address is 1.8. So because, or the IP address in IPtables is 1.7. Because I'm not 1.7, the only thing visible to me is going to be port 80. Everything else is going to be closed. By doing this, we limit our attack surface. So now, even though we haven't really patched the vulnerabilities, we're preventing the outside world from attacking them. It's a layer in our defense. It's not a control that gives us an excuse not to patch, but it buys us time to limit the attack surface. Remember, it's all about layers. So let's go ahead and change our ifconfig IP address to the one that is allowed. Okay, so ifconfig space ETH0 is the name of our internet card, network card. We change the IP address to the one that's allowed. Let's run nmap scan now, and notice the state shows as open. Okay, if we were to SSH using MSF-admin, add the target, eventually we'll be asked for a password, and once we provide the correct password, we're given a shell. Okay, let's see what happens. We change our IP address to .1.8, and here's the confirmation. And if what happens when we execute the same command, and we wait a little bit, and we shouldn't be able to connect because our IP address is not in the authorized list. So there is no point if kind of looking through this. If we look for kind of the port and all this, we'll see that we actually are not even seeing the port 22 is open. Filter tells us there is a firewall. Okay, so how do we actually edit? If we go in and enter, in order to execute the IP table commands and add these different rules, we need to be logged in. Okay, we need to elevate our command here, MSF-admin. From here, we're going to use the nano editor. Okay, nano, and we can go to ITSI, IPtables. The saved rules are going to be looking like this. Again, I added the comment fields, but for you should be able to see these input and so on saved like that. Okay, so if you see these just like this using the up and down arrow, you can navigate. In order to see look to the right where the cursor is, you got to move your arrow to the right, and it kind of helps you to display the rest of the line. To exit out of this, or to manually edit anything, you can do the control and then number 6. So control, hold down control, number 6, and then X. Okay, and this will get you out of this if you don't need to edit anything. If you do control and X, you'll be able to ask to write to the file and make any changes. Now, with the actual saving of this file and appending it to the interface, what we need to do is edit the ITSI network interfaces file. Okay, in this file we need to append the following: pre-up IPtables restore with the arrow pointing to the left, and then IPtables rules, and then the next one is new rules. Okay, so we hit the Control and X and we save those. Let's go ahead and do it again. So I'm gonna add a line here. I'm gonna do 8. See what it says at the bottom here. Look at this. So look at the symbol, and X is exit. So because I added, I do Control 6 and X, and then I'm asked, do I want to save it? In my case, no, but in your case, if you're making a change, it will be yes. And then once you press Y for yes, you'll be asked, if you want to write it, press enter and be written. Okay, so this kind of demonstrated of what happens when we leverage the power of the host-based firewall to help us limit the attack surface of our target.